This is the concluding discussion on matter, and today's topic of discussion is evaporation. We will actually do a comparative study between evaporation and vaporization or boiling. A liquid changes into vapor by the process of vaporization or boiling, but there is also one associated process that is called as evaporation. Now, evaporation, unlike boiling occurs at a fixed temperature, but evaporation occurs at any temperature. It is not necessary that there will be a fixed temperature at which evaporation will occur. Evaporation occurs at all temperatures, whereas boiling occurs at a specific temperature. For example, water boils at 100 degrees centigrade, but water evaporates at all temperatures. Unlike boiling, evaporation involves the surface of the liquid. So you can say that evaporation is a process of conversion of liquid to vapors at any temperature, and evaporation definitely occurs at all temperatures. It is a very slow process. Evaporation is a very slow and gradual process, unlike boiling, which is a very fast and very random process. It is fast and violent, but evaporation is slow and gradual. Evaporation involves the surface of the liquid. The molecules at the surface of the liquid are involved in the process of evaporation. The molecules at the surface. So it is a surface phenomenon, you can say. Evaporation involves the surface of the liquid. So the liquid evaporates from the surface, the molecules at the surface escape and they get converted into gaseous form or vapors. But boiling will occur at all temperatures. Boiling is very fast, it is a violent process, and boiling will involve the entire liquid. All the molecules of the liquid will undergo motion, and thereby boiling will occur. Not only that, evaporation produces a cooling effect. Whenever a liquid evaporates, it produces a cooling effect because evaporation needs some amount of heat, and that heat is extracted from the surroundings, which get immediately cooled. So evaporation produces a sensation of cooling. But this is not true in the case of boiling. There are many examples which involve the process of evaporation. For example, if we take some volatile liquid such as alcohol or ether in our palm, the liquid evaporates and it produces a cooling sensation on the palm. Similarly, if we blow some air over a hot liquid, say for example tea or coffee in a cup, definitely that will increase the process of evaporation and thereby it will start to cool. So there are various examples in our daily life where evaporation provides a benefit. In comparison with boiling, exactly you can say that some phenomena are exactly opposite in comparison with evaporation, but with respect to the molecular model that we have previously discussed in the case of boiling, that molecular model is also effective while discussing evaporation. So we know that the molecules of any liquid are in random motion Now these molecules are in random motion within the liquid itself. So some molecules while in random motion will definitely collide with other molecules and they will gain sufficient kinetic energy and come to the surface and escape. And that's why the molecular model is effective also in explaining the behavior of the molecules at the surface of the liquid that produces evaporation. Now evaporation depends on certain factors. Evaporation depends on the temperature of the liquid itself. If the temperature of the liquid is high, then the evaporation or the rate of evaporation is quite faster. Temperature of the liquid. More is the temperature of the liquid, more faster will be the evaporation. Evaporation also depends on the area of the surface which has been exposed to air. More is the area of the surface of the liquid exposed to air, faster will be the rate of evaporation. And it is a very common phenomenon which we can observe in our daily life. Suppose we want to cool some hot coffee or hot tea. We generally pour that hot coffee or hot tea on a saucer, and a saucer having a large surface area, it allows the liquid to cool faster, which means that the liquid evaporates will evaporate faster if the area of the surface is increased. Also, if a wet cloth is to be dried, it is generally spread out rather than kept squeezed so that water evaporates faster from the exposed area of the wet cloth. Evaporation also depends upon the nature of the liquids. Volatile liquids which are having a low boiling point will evaporate faster as compared to liquids which are having a high boiling point. So effectively you can say that volatile liquids will evaporate at a faster rate, and that evaporation obviously produces cooling. Volatile liquids, for example, petrol, kerosene, alcohol, ether, these are liquids which will evaporate at a faster rate because they have low boiling points and they are volatile in nature. If some air is blown over the surface of the liquid, then evaporation will definitely increase. The rate of evaporation will increase and evaporation will become faster. If air is blown over the surface of the liquid, then rate of evaporation will increase. If air is blown over the surface of the liquid. And the last factor on which evaporation depends is humidity. Now, liquids evaporate at a very slower rate if the weather is very humid. So, humidity will definitely decrease the rate of evaporation. In dry weather, cloths will evaporate at a very faster rate, whereas in humid weather or in rainy season, the cloths will dry at a very slower rate. So definitely increase in humidity will definitely decrease the rate of evaporation. So these are more or less some factors on which evaporation depends. So now we try to explain evaporation on the basis of the molecular model, as we have discussed in the case of boiling. It definitely depends on the motion of the molecules from molecular model. The molecular model involves the motion of the molecules, and so it involves the kinetic energy of the molecules, and therefore you can say that evaporation can also be explained on the basis of the molecular model. As in liquids, the molecules are always in random motion. They are in random motion within the boundary of the liquid, and so as they are in random motion, they will frequently collide with each other, and during collision, some of the molecules which are below the surface of the liquid, they will gain certain kinetic energy, and after gaining kinetic energy, they can overcome the force of intermolecular attraction, and as they overcome the force of intermolecular attraction, definitely this will increase the intermolecular spacing, and so those molecules will move to the surface of the liquid. They will absorb some amount of heat from the surroundings and they will escape out to the atmosphere. So definitely you can say that molecular model can also be used to describe the process of evaporation. Let me repeat again. From the molecular model or the molecular model viewpoint, you can say the liquid molecules are always in random motion. Liquid molecules in motion collide with each other. And gain kinetic energy. Now, after gaining kinetic energy, some of the molecules below the surface of the liquids on gaining kinetic energy, they will overcome the force of intermolecular attraction, Now, if they overcome the force of intermolecular attraction, the intermolecular space will increase. Space increases, and as intermolecular space increases, the molecules come up to the surface and gain heat energy from the atmosphere. As intermolecular space increases, the molecules just below the surface reach the surface and extract heat from the atmosphere or the surroundings. Heat from surroundings. On extracting heat from surroundings, they will evaporate to the atmosphere. So this is how evaporation can be explained on the basis of the molecular model. Evaporation is a very slow and gradual process, as I have already told. There are many applications of evaporation in our daily life. Evaporation produces a cooling sensation. An application of this is doctors generally prescribe to put strips of wet cloth on the forehead of a patient having high fever, because definitely from the wet cloth the water will evaporate, and during the process of evaporation it will extract some heat from the body of the patient and thereby produce a cooling sensation and reduce the temperature also. As I have already discussed, that we generally pour hot coffee or hot tea in a saucer, and definitely it increases the surface area and evaporation becomes faster, it produces a cooling sensation. Also, we generally blow air over a cup of hot coffee or tea, so to increase the rate of evaporation. As we already told, that evaporation depends upon the amount of air blown over the surface of the liquid. We use certain earthen pots in summer season, and the use of earthen pots is that water kept in those earthen pots, they will seep out through the pores of the earthen pot and evaporate, and that will produce a cooling sensation. and the water trapped in the earthen pot remains cool for a longer period of time. So there are many such applications where evaporation provides a benefit. Evaporation, unlike boiling, is slow. It takes place at all temperatures and it involves the surface of the liquid only. It never involves the entire liquid. So you can say that evaporation is a surface phenomenon, whereas boiling is a bulk phenomenon because it involves the entire liquid.